Let's take up the next problem, dear students. It's like this. Let xy plane be the boundary between two transparent media. Medium 1 with z greater than or equal to 0 has a refractive index of √2 and medium 2 with z less than 0 has a refractive index of √3. A ray of light given by vector A is equal to 6√3i plus 8√3j plus 10k is incident on the plane of separation in medium 1. The angle of refraction in second medium is options 45 degree, 60 degree, 75 degree and 30 degree. Dear students, it's a very beautiful problem. Here it's mentioned that light travels from one medium to the other medium, and those two media are, in the first medium z is greater than 0, that is positive, and in the second case, in the second medium z is negative. Let me say that this is the interface which separates those two media. This is first medium of refractive index √2 and this is second with refractive index √3. Ray of light travels from first medium to second, so rarer to denser it has to bend towards the normal. And using simple Snell's law you can calculate sin r, that is angle of refraction, provided angle of incidence is known. But here angle of incidence is not given. The beauty of this problem is the incident ray is given in vector form, using which you have to find out angle of incidence first and then find out the angle of refraction using Snell's law. Let's understand the problem like this. This is the interface which separates two media. It is mentioned that it is xy plane here. This is xy plane, and what is normal to xy plane? Obviously it has to be the z axis which is normal to xy plane. So this is my z axis. Now the incident ray is incident like this. Let me say that this is incident ray. It is given by vector A. Let me write that vector A once again. It is 6√3i plus 8√3j plus 10k. Now if this is incident ray, if this is the normal to the surface, then what is angle of incidence? Angle made by the incident ray with the normal is angle of incidence I. But let me write down those two media first. This is first medium with refractive index √2. This is second medium with refractive index √3. Now obviously this goes like this, and find out this angle is the question. So let me find out I first, as I've already mentioned. So I think I can make use of the properties of vector, and it is, there is a triangle formed here. Let me complete the triangle. What does this line indicate? So the magnitude of this portion, it indicates the z component of this vector. Look at this. I want to find out angle of incidence I using this triangle. So in this triangle, what all do I know? This is the z component of the vector I, it is just 10, and what else I know? This is the magnitude of the vector. I can easily find out the magnitude of this vector. So I think I can make use of trigonometric function. I think cos I can be found out here. Cos I is adjacent by hypotenuse. Let me work it out. Cos I is, what is adjacent? The z component of vector A is 10. This is 10 from here to here. So 10 divided by adjacent divided by hypotenuse, that is the magnitude of this vector. As you all know how to find magnitude, the square root of sum of the squares of these coefficients, 6√3 square plus 8√3 square plus 10 square under root. So this is 10 divided by 36/3 is 108 plus 64 into 3 is 192 plus 100 under root. This turns out to be probably 300 plus 100 is 400 under root is 20. 10 by 20 is half. Cos I is half, which gives me the value of I to be 60 degree. If I is 60 degree, then find out R using Snell's law. Obviously it has to be less than 60 degree. You can easily eliminate two options B and C. Answer has to be either A or D. Let's work it out using Snell's law, which is N1 sin I is equal to N2 sin R. This gives me N1 is √2 sin 60. √2 sin 60 is equal to √3 sin R. So sin R, what is sin 60? √3 by 2. So √2 times √3 by 2 is equal to √3 into sin R. √3 gets cancelled. I am left with 1 over √2 in LHS. So R should be 45 degree. Sine inverse of 1 by root 2 is 45 degree. R is 45 degree. Option A is the correct answer. Dear students, let's take up a beautiful problem which is asked in one of the previous IIT JEE paper. It goes like this: a light ray traveling in glass medium is incident on glass air interface at an angle of incidence theta. The reflected and transmitted intensities both as function of theta are plotted. The correct sketch is. There are 4 graphs given. Students, in most of the cases while discussing refraction, it's a common tendency to ignore the fact that during refraction light also gets reflected, right? And this problem doesn't allow us to ignore that. So out of 4 options we'll have to pick out the correct option, and here they are plotted, these intensities are plotted as a function of theta. Do we know any concept what happens to a ray which is traveling from denser to rarer medium? Yeah, when we talk about the propagation of light from denser to rarer, we have to think about total interreflection which takes place after some angle called critical angle. And is that concept depicted correctly in any of the options? So what happens after some angle theta? There won't be any transmission. It is completely reflection. So look at options A and D. These suggest that from 0 to 90 degree you have transmitted intensity. So which is impossible. Look at these two. These two say that transmission takes place from 0 to 90 continuously. So these two must be wrong, because after critical angle no transmission at all. It is 100% reflection. Look at options B and C. These two depict this concept clearly. That is, after some theta no transmission at all. Look at this, after theta no transmission at all. So out of these two one must be the correct answer, B and C. But what is the difference between these two? They both of them look alike, but the only difference is at angle 0 degree. Look at angle 0 degree. B says that at 0 degree transmission is 100%, reflection is 0%. And C says that at 0 degree transmission is less than 100%. And some portion of light also gets reflected. What is correct out of these two? Yes, even at 0 degree, when the ray travels from denser to rarer, it's not only transmission which takes place, some portion of light also gets reflected back to the same medium, and the remaining portion gets transmitted. So option C correctly says that only a small portion of light gets reflected and transmission is not 100%. So this satisfies both the conditions which I mentioned. Therefore, option C should be the correct answer. Now let us take up a problem on prisms. A ray of light PQ is incident on an isosceles glass prism placed on a horizontal table. If the prism is in the minimum deviation position for the ray PQ, which of the following is true? Options: alpha is equal to beta, alpha is greater than beta, alpha is less than beta, alpha plus beta is equal to 90 degree. Dear students, this is based on a fundamental of prism when kept in minimum deviation position. You will have to know the important features which the prism exhibits when it is placed in minimum deviation position. Let me write the diagram once again. Let us have a look at the given diagram. Since it is isosceles triangle, these two angles are equal and this is alpha And is there any connection between alpha and betas? That's the question asked. So when the prism is kept in minimum deviation position, when a monochromatic ray passes through the prism, let me write the diagram. Draw normals. So this is angle of incidence I, angle of emergence E, angle of refraction R1, R2 on two faces, angle of prism, let me write this as ABC. Now what are those important features the prism exhibits under minimum deviation condition? As you all know, you will be making use of the formula for refractive index, n is equal to sin of a plus d by 2 divided by sin a by 2. The formula has to be made use only when the prism is kept in minimum deviation position. So let us understand what are the conditions for minimum deviation position. During minimum deviation, most important thing is the refracted ray, which is QR here, refracted ray will be parallel to the base. Let me list out those characteristics. It will be parallel to the base. Next, these two angles R1 and R2 should be equal under minimum deviation position. R1 should be equal to R2. Next, angle of incidence will be equal to angle of emergence only during minimum deviation position, that is I is equal to E. Next, very important thing is the ray passes symmetrically through the prism. The ray passes symmetrically through the prism. I will write that condition, symmetrically. Then at last but not the least, the ray suffers minimum deviation. So minimum deviation. So you can use the prism formula when one of these 5 conditions are given. So please do remember these 5 conditions. I think it will be very easy to remember if you write it in this order, these conditions. Look at this. How does it look like vertically? So you can find a prism here within these conditions. So look at the first condition. The ray should travel parallel to the base. So according to which the ray QR should be parallel to the base. But purposefully he has not written the QR not parallel to base. So he has tried to cheat you by not writing this parallel to the base. So what happens if QR is parallel to base? Alpha and beta will be corresponding angles. So corresponding angles must be equal. So what is the connection between alpha and beta? They are equal. If this is alpha and this is beta, they should be equal. Option A is the right answer. Let us look at the next problem. A glass dumbbell of length 30 centimeter and refractive index 1.5 has ends of 3 centimeter radius of curvature. An object is situated in air at a distance of 12 centimeter from the end of the dumbbell along the axis. Find the position of the image formed due to the refraction at one end only. The options are 16 centimeter, 18 centimeter, 20 centimeter and 24 centimeter. Dear students, this is based on refraction through spherical surface. Let me write the dumbbell shaped glass object first. It will be like this. Yeah. Along the axis, place an object at a distance of say some 12 centimeter from one surface. This is that surface which we are considering, and this distance is object distance. It is given to be 12 centimeter, and due to refraction at this surface, you are supposed to find out the position of the image. So let us take up the refraction through spherical surface related formula, which is n2 by v minus n1 by u is equal to n2 minus n1 by r, where N2 is the refractive index of the second medium, N1 for first medium, R is the radius of this curvature. U is given to be 12 centimeter. Find out the position of V. It's a simple problem, right? N2 will be 1.5 divided by V is to be found out, minus N1 is, since it is surrounded by air, 1 divided by the object distance is negative. This is incident ray direction. So, measuring in the opposite direction has to be negative, is equal to 1.5 minus 1 divided by radius of curvature is 3 centimeter. So, rearrange the terms, 1.5 by V plus 1 by 12 here. So, I will take it on the other side. It is equal to 0.5 by 3 minus 1 by 12. This can be written as 1 by 6 minus 1 by 12. 1 by 6 minus 1 by 12 is like 1 minus half, which is half only, that is 1 by 12 only. So, 1 by 12. So, 1.5 by V is equal to 1 by 12. Let me write 1 over V is equal to 1 by 12 into 1.5, which is 1 by 18. This gives me V is equal to 18 centimeter. Option B is correct. Look at the next question. A concave lens forms the image of an object such that the distance between the object and the image is 10 centimeter and the magnification produced is 1 by 4. The focal length of the lens will be options A minus 6.2 centimeter, B minus 4.4 centimeter, minus 8.6 centimeter and minus 10 centimeter. Yeah, all the 4 options have to be minus since it is a concave lens, but how do we get the exact value of it? They have given you the distance between object and image and also the magnification. To find out focal length, somehow we will find out U and V, then using lens formula we will calculate the focal length. Let me write out the concave lens first. It always produces a virtual image. If I say that this is the object, irrespective of the position of the object, image is always virtual, which means it is always formed on the same side as that of the object. So, and it should be within focus, within focal length, your image will be formed. Let me say that this is that image formed, which is virtual. Now, is there any information given with the distances of U and V? No. The magnification is given. Let me straight away take down the magnification. M is equal to V by U, which is 1 by 4, which gives me U is equal to 4V. So, if I say the object distance is 4 times that of the image, if the image distance is x, then object distance will be 4x. But one more data is given, that is the distance between object and image, it has to be 3x, 4x minus x is 3x, it is given to be 10 centimeter. So, 3x is 10 centimeter and x is equal to 10 by 3. So, now I got object distance and image distance. Your image distance is x, object distance is 4x with sign conventions. Remember, both of them are negative according to sign conventions. Therefore, U is equal to minus 4 times x, 40 by 3, and V is equal to just x, it is minus 10 by 3. Take out lens formula now, which is 1 over f is equal to 1 by V minus 1 by U. So, this is minus 3 by 10 minus of minus plus 3 by 40. So, this is minus 12 plus 3. So, minus 9 by 40 is your 1 over f. So, what is f? 40 by 9 with a negative sign. 40 by 9 is 4.4 centimeter. So, that gets me option B as the correct answer.